Right, we'll be giving it a go now. So what do we have up in here? I see. We yesterday talked about the STLC. We finished STLC completely. Like what we do in which phase of STLC? We need requirement analysis, test planning, test case development, environment setup, test execution, and test case closure. Now, next we'll be talking about different types of testing, but before, just a quick short topic. QA, QC, and also we'll talk about testing up in here. See, basically, these terminologies are used can say interchangeably, but there is a difference between these. QA, if I talk about, it primarily focuses on the process improvement, right? So when you talk about QA, it's going to be a process improvement process, wherein we'll go with the PDCA cycle, which is your plan, do, check, act cycle. This would be primarily done by those experienced folks who are there in the industry for more than 5 years. They are your experienced developers, experienced QAs. They will form a team actually to improve the overall process, right? And for that, they'll first go ahead and plan that, and they'll define the tests that they need to do. They'll evaluate based on to those tests. This is not the testing of application. This is actually verifying that the process is, because if the process is good, then there will be no issues. Yeah, this is what like they'll first plan, then they will develop the testing approaches, then they'll verify based on to that testing, and they'll act. They'll take the necessary me measurements to improve the overall process. Then comes something known as quality control. Quality control is primarily focused onto the product or that service. QA earlier was for the process. QC here is for the product. So you have nothing to do with the process here, but you would go with the quality of the end product examination, right? That is how we go ahead with the quality control. And if this is properly identified, then QC will simply evaluate the people on their quality level skill sets, and it will impart training inside. It is also the quality of people as well. And that's why when you talk about these three, QA, QC, and testing, if you do a quick comparison, then QA, as you can see here, is primarily the activities to make sure the implementation of process, procedures, and standards. QC, on the other hand, is the verification of developed software, that is product. And testing is all those activities using which you identify the errors in your software or application. That's why it is focusing on processes. It is focusing on actual testing for the software, and it's also focusing on the actual testing. But primarily, if you'll see, here we have the process-oriented activity. Here we have product-oriented activities in these two. QA is a preventive activity. Testing is also a preventive, but you make changes during the QC. And if you look at the hierarchy here, on top of that, as you can see, there will be SDLC, right? Under the umbrella of SDLC, you have SDLC. Under SDLC, you have QA. Under QA, you have QC. Under QC, you have test. That is how we have these. Is all defined, right? This is what we have in here with this. So this is where we can conclude this module, but I'll just share this with you. And we will go with the next one. Let me share my screen again. Before that, let me share both of these modules and the one that we are going to start. So all the testing modules I'm sharing in the chat. Wait, is that? Now we'll go with types of testing. All right. Now see, so far we talked about introduction to testing and STLs. Now we will discuss what are the different types of testing. In that we'll also get to know about the levels as well. Then we'll jump on to the test case design techniques. That we'll do next. Okay. Right now, what are the different types of testing we have available here? Now, when you talk about this, we have functional, non-functional, and then we have black box, white box. These four are not types. These are basically levels. That is what we're going to talk. Now, when we talk about the types, first you'll be landing on to functional and non-functional. See, that's what I was talking about. These are the types, and these are the levels, four levels. That is the difference. So we'll talk about each of these. First, we'll go to functional testing. Now, functional, as the name suggests, you will simply verify the functionality of the project, of the application. You're inserting some input, scrutinizing the output, just to check whether you're getting that properly or not. You'll go with the creation of test data as per your requirement of the application. You'll check whether the output is depending upon your application or not, and then you will flag that as an error. That's how. So you simply compare the actual and expert. And this is what I showed you in that test case also. So this is functional testing, which you will be primarily involved into. Non-functional also, I have told you earlier that in case of non-functional, what happens is you go with testing any application for the requirements which are non-functional. Now see this functional and non-functional now. These are basically based onto the requirements. Like functional testing, we do testing based onto the requirements. So functional testing will be based upon functional requirements. And non-functional testing will be based upon non-functional requirements. So non-functional requirements we have discussed already earlier. So we have UI, performance, and security. You remember earlier I talked about this, that non-performance is always what you don't have covered in the performance there. That is how it is all about. That is how it is all available there. Right? We talked about the performance also earlier. Security. These are all non-functional requirements. So if you are testing for these non-functional requirements, then just your non-functional testing. Then comes black box and white box. Now, black box is what? See, it's very simple that you have a box. You actually consider your application as a box, and that box you are simply painting it black. Now, because it is black, you don't know what is happening inside. And then what you do is you simply provide input and you check for the output. Now, there is a process in here to convert that input into output, but you don't know you don't know anything about it. Okay. That is black box. You don't know what is happening internally because see, when you talk about the application, this process, what is this process? In case of application, this process is basically some code. But because it is black box, you have no idea what this code is all about. You don't understand that code. That is primarily what you do, being a QA, because you need not to learn programming for this. You just need to check how well your this application is conforming to these requirements. You being a QA, you have no idea about the system architecture. You don't have access to the source code. Source code is your programming language code. You have no idea about that. And when you're performing this black box testing, you will interact just with the UI, user interface, UI. You will simply provide inputs. You'll be examining outputs without knowing how and where these inputs are actually workable. Now, black box has its own advantages where it is very well suited and efficient for your large code segments here as well. You need not to get the code access And with that, actually, it is able to completely and clearly separate the user's perspective from the developer's perspective through those visibly defined roles up in here. We'll need some large number of moderately skilled testers which can test the application with even with no knowledge of implementation, no knowledge of programming language, or no knowledge of operating systems up in here. That is the best advantage with the functional up in here. Because black box will simply go ahead with that. But they say that you get limited coverage because you'll be going with a selected number of test scenarios. I won't say inefficient, it's just that from the QA's perspective, it is more than enough. Because you don't have limited knowledge actually. You get all the knowledge about the application for requirement from requirements only. And based on to that, you will test it. It will have blind coverage because the tester cannot target any specific code segments or prone areas because you do not have access to the code. I won't say difficult. It is just that it is not that easy to come up with these. Comparatively, it looks difficult when you compare that to the white box because white box, the one that we have next, white box actually, this box that we had earlier, now this box is completely transparent. So whatever code is inside your application, you can see that. Because what would you do here with these white boxes? You will primarily check the logic of your application, structure of the code, logic of the code. You will test the code of your application. Will have like statements, branches, path, decisions, data flow, everything you will test in the application code. And you do it so that you can improve the code. And improving the code will eventually, ultimately, improve the application as well. Now, the test engineer needs to have a look inside your source code. It has to find out like which specific part of your code is not behaving appropriately. That is what you will check in this white box testing. This is also coming up with a lot of advantages. Like you will have the knowledge of the source code, so you will be able to find out like where actually the problem is. And with this, you can optimize the whole your programming language code. You can even remove these extra lines of code with the which can actually introduce some hidden defects. And because you are someone who knows the programming language code. You will have all of that as scenario writing. But at the same time, it comes up with some disadvantages as well because to do this, you need a skilled tester. When you say skilled, it's not about skilled in testing, it's about skilled in programming. So that would actually increase the overall cost. And sometimes it is impossible to look into your every nook and corner to find out what are the errors, right? And it is difficult to maintain these white box testing as well. Because for this, you need code analyzers and debugging tools, which needs to be in there. Now we have levels. Levels, I told you that we have these four as the levels, wherein these all will go in the same sequence. Because yes, these are also part of types of the testing because the types also we have these. But when we are treating these as levels, you don't change the order. So when you're testing the application, first perform unit testing, then integration, then system, and then acceptance. I will talk about each of these. When you say unit testing, now what actually this unit testing is? See, we have, let's say, 5 developers in your team. Right? Now, every developer is developing unit, right? So that developer, now see, your software application will be some parts. We are calling these parts because every developer will develop its own part of the application. And then all of those parts will be combined together and then it will be sent to the tester for testing, right? That's how it all happens. Now, before this merging of all these components are happening, these developers will test this unit, individual unit, what that particular developer has created. So it is like every developer is testing its respective unit that it has created. That is unit testing. Now, if I'm creating something, before I'm giving it to the other developers to combine that with their individual units, I'm just giving a test that, okay, I developed this, at least it is working fine on my machine. That is unit testing. So you use your own test. If you're a developer, you'll use your own test data. Because see, the goal here is to isolate each part of your application and show that the individual parts are correct when it comes to requirement and functionality. Individually, it's working fine. Then we'll merge everything and share that with the test team. And that's why we have some limitations in unit testing as well. Because this, you can't catch each and every bug because you're testing that in as an individual. So individually, whatever possible, you would have done that. Plus, you'll have a limited number of scenarios and test data as well because you're simply verifying the source code. And once you're done with all of those, you will simply stop your unit testing and you'll merge that code segment with the other units. That is what you would do with the unit test. So unit, what you did, you were a developer. That's why this is primarily done by developers. 90 to 95% unit testing will be done by their respective, for those modules, by their respective developers only. Now, once you're done with the unit, then comes integration. Integration is what? Developer 1, developer 2, developer 3, developer. So let's say they have created their individual units. So basically the modules, all of those are combined as one application. And shared with the testing team for further testing. Now, what test team will do here is, because in the test team also we have so similarly, we'll have QAs also, different number would be different. But now QAs will be assigned to test functionality. Feature 1, feature 2, feature 3. So earlier, these features are checked properly. During the unit testing by the respective developers. But then those features are combined with other features. Individually, those are working fine. That's why we went ahead because that was the result of unit testing. Now, all those are combined. Now, while combined, whether these can work properly or not, that is what we check in the integration testing. So you can check that here in the integration testing. That's why we have three types: bottom up, top down, hybrid. In case of bottom up, your testing will start with unit. Then you will go with the higher level combinations of units. Because you have multiple of these units modules. So you go with the higher level, lower level, then you go to the higher level. Top down, you start with higher level and you go to lower level. That is what you have with this bottom up. Top down says that you go with highest number, highest priority first, and then you go with the lowest one. Hybrid says, let's just go with the priority. What client needs first? Let's just do that first. So that you could have a mix of both. That is, mix of bottom up and top down, and you go that with hybrid or sandwich integration. Now, unit testing is done for the individual components by the developers. Then those are all combined, and then your integration test team has done a testing while everything is combined. But even being combined, you would have noticed that they will be testing the individual functionalities only. Till this time also, we have not tested our application as a whole. We're only focusing on the software aspect. What about the hardware aspect? What about the networking aspect? Right? Because we were only focusing onto the software, but an application is not just software. Hardware, networking, all these also needs to be taken care of. Because ultimately, you will be delivering this application as a whole to the system. Because as you can see, right after the system testing, what we have is acceptance. Now, acceptance is where you will call out the customer. Now, before you're calling out the customer, you need to test your application as a whole complete system. The code, hardware, network, anything that you need to check. You'll check that everything. Because now you will look at the application at the entire system level. You're not talking about the individual components. Now, individual components are tested here in this integration already. So that's why in system testing, there will be multiple testing types, which you will validate the software, hardware, network part of your application. So a lot of testing available here, GUI, functional, progress, regression, smoke, load, stress, security, ad hoc, everything is system testing, right? And system testing is having its huge importance here. Because when you go with this system testing now, have that all available there. That is what you can check in here. So system testing is primarily the first time when you are going with the application being tested as a whole. right? Now the application you will test completely thoroughly to verify whether it is meeting all the functional and technical specifications. Now the application is actually tested in the environment, which is very close where it is going to be deployed, right? So we will go with the system testing, which will enable us to test, verify, and validate not only the business requirements, but the application architecture as well. That is how it is. Right? So system testing will make you to test, verify, validate not only the business requirement, but the application architecture as well. Now, once that is all over, we go with the acceptance testing. That's how it is. Even when you talk about the acceptance, acceptance is all about getting that being accepted by the the client. Because until unless the client is accepting that, that's how it is, right? That's when it will go with that. So in this, your customer will be there. So now your customer will actually perform this acceptance testing to tell you. That's how it is. So all those acceptance tests will be performed on the application, and the customer will tell that okay whether he's happy with the application or not. Now see, the thing here is in this case, because the customer is going to accept or reject, that is how it is. This is acceptance testing. The client will deduce that okay, yes, we are accepting that. That is how we have that. That is how it is. So this is all about the acceptance testing. Even when you'll say that, your customers will be saying that, okay, whether it is all available up in there or not. That is how it is. Right? That is, these are all four levels that we have. Go in this order. You can't change the order. First, there will be unit, then it will be integration, then it will be system, then only it will be acceptance. So these are all we discussed the levels. Now next we'll go with the types of other types of testings that we have, but that we'll discuss tomorrow. So today we went ahead with discussing what are these different types primarily. So we had functional, non-functional, white box, black box, and then we talked about the four levels of testing, right? But we got for then.
So I have a question real quick.
Yes, please.
Um, are we going to get into like the practical part of doing this actual testing?
Yes, of course, because in our next module, we're going to learn what are the testing techniques, test design, and then we'll test a live application. I'll make you all create the test cases and test an application.
Okay. And then so during the interviews, they're going to ask us these kind of questions like, what types of testing do we know and how well can we do them?
Yes, they might ask
Uh,
you or a specific
they
question.
might.
So, yes.
Okay. So, is that something that we're going to cover during the interview prep, or is that something you're going to ask us to do once you've taught it to us?
No, like here itself, in like during the session itself, we're going to do all of this.
Okay. Okay. That sounds good. Yeah, I was just curious because I was trying to figure out what sort of questions they're going to be asking us during the interviews. So I wanted to like focus primarily on that. But yeah, I understand what you're saying now.
Yeah, so basically for that, what we'll do is we'll also share that. I'll also share some general interview questions and answers with you. Plus the
Oh, okay.
interview prep actually we will do depending upon the JD. So let's say if you're being interviewed for some specific job description, but so every job description will have a separate preparation before the interview.
Yeah. And then so that's what I'll prepare for accordingly. Like we'll work on that together to figure all of that out, other than the training.
Yes, exactly. That will also
Okay,
be,
okay.
right?
Yeah, that sounds good. I was just trying to figure out what we're going to do moving forward after the theoretical part, but I understand now there's a whole plan in action.
Plan. Yes, it is. It is that. It is that.
Okay, I got you. I guess if we're done, then we can just get going.
Yeah, sure. Yeah. Bye.
All
Take
right. And then do we
time.
have a session tomorrow? It's a public holiday, I think.
Mm, yes. But yeah, it's just gonna be 1 hour, so not gonna be an issue, right? So yeah.
Okay, that sounds good. I'll be here.
Yeah, all right. Take care.
All right,
Yeah.
thank you. Bye bye.